So, welcome back, students. Hopefully, all of you will be fine. In our last video, we have completed up to question number 13, and in this video, we will cover the remaining questions from 13 to whatsoever number up to which they are. And if you have any doubts regarding previous video, you can comment. I will try to clear it. So, going forward, let us solve question number 14. So let me check the pen width. If I need to adjust it, yes, it needs to be adjusted slightly. Now seems okay. So a man of 50 kg runs up a hill, rising himself vertically 10 meter in 20 seconds. Calculate the power. So it's like this. There is an inclined hill. Man walks over it like this and reaches here. I think it's still slightly thick. So, and his weight is 50 kg. When he goes from ground, or you can say point A to point B, his height increases by 10 meter. So this increase in height is 10 meter. Some of might you consider that this is 10 meter, but here it is mentioned as vertically 10 meter. If it has been mentioned that he traveled a distance of 10 meter, then this should be the 10 meter. But if it is mentioned that the increase in height or vertical distance covered by him is 10 meters, then we have to consider only y-axis distance. So this is our y-axis and this is x-axis. And the time he took is equal to 20 seconds. So time is 20 seconds. Height is 10 meter. His weight is equal to 50 kg. Now he moved vertically. So I have explained you previously, you can use it as a shortcut that if there is a vertical movement, although it may not be necessarily applicable everywhere, but in your most of the cases, to the level which you are studying right now, if there is a vertical movement, it will be equal to change in potential energy. Okay. Oh, and if there is horizontal movement, then there will be change in kinetic energy. Okay, so there is vertical movement as height is increased, so either it can ask work, energy, everything that will be equal to change in potential energy. So here work or energy is equal to change in potential energy, and its formula is mgh. So m is 50, g is here mentioned strictly that we have to use 9.8, else I have been using 10 because multiple of 10 I have might used 10, but here it is mentioned that I have to use 9.8 and height is 10, so we will separate the point by dividing 10. So here answer comes out to be 50 into 98. We will not solve it because we have to use its further calculations. Now it is mentioned to calculate the power. Now what is power? Power is rate of doing work. energy by time or work by time. So, and work and energy are same thing. So work here is 50 into 98 and time is 20 seconds. So to cancel, it's 49. It comes out to be 245 watts. Okay. So this solves our question number 14. Moving to next question. Question number 15. A rickshaw puller pulls the rickshaw by applying a force of 100 Newton. So force is 100 Newton. If rickshaw moves with a constant velocity, here look, it is mentioned as constant velocity. So first of all, velocity's value is 36 kilometer per hour. It is in kilometer per hour. We have to convert in meter per second. So we will do this conversion. Kilometer will be equal to 1000 meter and per hour is divided by hour. So it will be equal to 3600 seconds. So 10 remain as it is, 36 gets cancelled and answer is 10 meter per second. And there is further one thing which you have to look very carefully. It is mentioned as constant velocity. It means velocity is not changing. Now what does it change? Means what is the meaning of this term constant velocity? You might remember we have studied acceleration. Acceleration is equal to change in velocity by change in time. This is delta v is change in velocity. Now velocity is constant, so velocity does not change. So delta v is equal to 0. So acceleration is 0. Now if acceleration is 0, force is mass time acceleration. So if acceleration is 0, force is 0. Now going further, what is work? Work is force into distance into cos theta. If force is 0, then work is 0. And if work is 0, we know what is power. Power is work upon time. So it is, if work is 0, then power is also 0. Okay. So you can draw this conclusion from this whole scenario that displacement, if we have change in displacement, then we get velocity. From change in velocity we get acceleration. From acceleration we get force. From force we get work, and from work we get power. If delta v is equal to 0, implies acceleration equal to 0. If acceleration equal to 0 means force equal to 0. And if force equal to 0 means work is 0. And that further means that power is 0. For power we can devise another formula, as we know that power is work upon time. And what is work? F into d into cos theta. So F into d into cos theta by time. Here d is displacement and t is time. So we get force into velocity into cos theta. So here velocity is not changing, so this is 0. So from this you can also find out that power is 0. But for you can use this simple analogy, this simple path to find out that if velocity is not changing, there is no acceleration. There is no acceleration, there is no force. No force means no work, and no work means no power. Okay. Going to question number 16th. It is mentioned that athlete weighing 60 kg runs up a staircase having 10 steps each of 1 meter. So there are 10 steps, means 10 stairs are there. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. This is ground level. Okay. So 10 step, each height of 1 meter. So this height is 1 meter. This height is 1 meter. So there are total 10 steps, then total height will be equal to total height equal to number of step into step height. Total number of steps are 10 and step height is 1. So total height is 10 meter. Okay. Now it is mentioned that it took him what is 330 seconds. So total time he took 30 seconds. Calculate the power. Now his mass is already mentioned 60 kg. Mass is 60 kg. So as we know, suppose here is the athlete. At starting he was at ground level. Now he is at the top level. So what have changed? His height has been changed. There has been vertical movement. Okay. And how much vertical movement? 10 meter equal to change in height. In case of vertical movement, what we take? Energy is equal to energy or work. Energy slash work equal to change in potential energy. Okay. So here work equal to change in potential energy, that is equal to the formula for change in potential energy is mgh. So mass is 60. G here is mentioned again. We have to use 9.8. So 9.8 means 98 by 10 and height is 10. So it is equal to 60 into 98. We will not solve it further because we have to calculate the power. Now power is equal to work upon time. Work is 60 into 98. Time is 30. So dividing, we will get 196 watt. If we have used G is equal to 10, then this will be 60 into 10. This will be 60 into 100. This will be 100 because we have divided by 10. So 2 into 100 is equal to 200 watt would be our answer. So it depends upon value of G. The answer might be slightly vary. It can be 200 or 196. Both are correct if G is not mentioned. If G is mentioned, like here, it is mentioned that you have to use 9.8, then all the calculations should be done using 9 point only. And in that scenario, using G is equal to 10 will be wrong and you will not any marks. But at least you should know the flow, that how to use that value. If you know the flow or the process, then you can easily solve the question. The value of G can vary, the value of your answer can slightly vary, but at least you should know the flow, that which steps you have to follow to get to the answer. That's show your level of understanding, that how much you understand the question and how good grasp you have of theoretical concepts. So going to question number 17. The heart does 1.5 joule of work in each heartbeat. How many times per minute does it beat if it beats its power is 2 watt? So in question it is mentioned that the heart takes 1.5 joule of work in each heartbeat. So we can say that for one heartbeat, heart requires 1.5 joule of energy. Okay. For one heartbeat, heart requires 1.5 joule of energy. From this you can say for two heartbeat, heart require 3 joule of energy. 1.5 into 2 is equal to 3 joule. Okay, that much clear. Now going it further, it is asked that how much times heart does beat if its power is 2 watt. So Hertz power is mentioned. Hertz power is equal to 2 watt. 2 watt means 2 joule per second. Okay. Heart means suppose heart has an engine. So that engine generate 2 joule per second, and out of that 2 joule, heart requires 1.5 joule for one heartbeat. So we have an excess of 0.5 joule. Okay. So you can say that every second heart has 2 joule energy available. ठीक है? Okay. Now it is asked that in a minute how much time heart will beat. So in 1 second heart has 2 joule energy. In 60 seconds or 1 minute, heart has 2 into 60 or 120 joules of energy available. Okay. Now for one heartbeat, it takes 1.5 joule, or you can reverse it simply that in 1.5 joule heart beats one time. We are just reversing it. For one heartbeat it requires 1.5 joule, or we can say in 1.5 joule heart beats one time. So in 1 joule heart beats 1.1 by 1.5 times, and we have in a minute we have 120 joule of energy. So in 120 joule heart beats 1 by 1.5 into 120. Solving it further, 10 by 15 into 120 go to 8. So 80 heartbeats or 80 times. So in a minute, if heart has 2 watt of power with 1.5 joule per beat requirement, heart can beat up to 80 heartbeats per month or 80 times per minute. Okay. Going to question number 18. In a question mentioned, calculate the time taken 60 watt bulb to consume 3000 joule. So it is mentioned that power is 60 watt. What does 60 watt means? 60 joule consumption per second. So 1 second, 60 joule of energy consumed by bulb in 1 second. 1 joule of energy consumed by bulb in 1 by 60 second, and we have given 3000 joule. 3000 joule energy consumed by bulb in 1 by 60 into 3000. So you get 50 seconds. So bulb will consume 3000 joule in 50 seconds. Coming to question number 19. Clearing the screen. Find the power. So we have to find the power. In question number 19, it is mentioned a horse exerts a force of 200 Newton to pull the cart. So force is 200 Newton. If the horse cart moves with a velocity of 36 km per hour on the level road, here velocity is given as 36 km per hour. We can convert it so this will get us 10 meter per second. Okay, and it is mentioned that on level road means scenario will be like this. This is road, this is our cart, and here is our horse pulling it. Okay, and horse and cart are tied together. So horse is applying force in forward direction and cart is also moving in forward direction. So displacement is also in forward direction and force is also in forward direction. So the angle between force and displacement theta is equal to 0 degree. Both are in same direction. Now we have to find out the power. Previously we haven't done a question here, just a similar question where it was mentioned that velocity is constant velocity, and in that question our power was 0. Here it is not mentioned that velocity is constant. Here we have just mentioned that velocity's value is provided, but it is not mentioned that it is constant. Let me look at that question. Here it is question number 15. In question number 15, see here it is mentioned constant velocity. In this question there was force and velocity. So, but due to constant velocity our power was 0. In this question there is again force and velocity, but here answer will not be 0. Here we will get a value of power that is not equal to 0, because here velocity is not constant. Here velocity is not constant. So means if velocity is not constant, we have acceleration. If we have acceleration, we have force. If we have force, then we have work, and if we have work, we have power. Now some of them you will can also ask that in previous question there was given that it has a force of 100 Newton. It was mentioned that force is 100 Newton and then constant velocity is given. So this is like that. Suppose this is the same case. The person is pulling the rickshaw. So to start the motion, you have to apply some force. It is that force. After object is started moving with constant velocity, means then you are not applying any forces. Let me explain it further. If you remember our law of inertia, in which we were discussing inertia of motion. and the statement of inertia of motion was, if no external force acts on body will maintain its state. Means if there is no external force is zero, then velocity will not change. Okay, so if external force is zero, then velocity will not change. So we can reverse it also, that if velocity is not changing, then external force is zero. That's why in question number 15 we consider that force is zero, and this force was starting force. To start the rickshaw, or to start the rickshaw, we need some force, and after some time when rickshaw has some velocity, then to maintain that velocity there is no requirement of any force, because it is now in inertia of motion, considering that friction is zero. In all these questions we are considering that friction is zero. So taking this consideration, you can say constraint, that friction is zero and rickshaw has been started and its velocity is not changing, means they right now at rickshaw there is no force acting on it. That's why its velocity is not changing, and that 100 Newton is the force that was required to start the rickshaw and to give it velocity to increase the velocity up to 36. Okay, but in this case it is not mentioned that velocity is not changing. Here it is not mentioned that velocity is constant. So we will assume that velocity is changing. If velocity is changing, then there is acceleration, there is work, then there is power. So if we write the formula for power, is work by time. Okay, now work is force into displacement, and we have already devised that theta is zero. So force into displacement into cos zero by time. Cos zero is 1, so it is force into displacement by time, and displacement by time is velocity. So answer is force into velocity. We have given force is 200 and we have calculated velocity is equal to 10 meter per second. So the power is 2000 watts, and we can also convert it into horsepower. Here it is also mentioned that you have to find the answer in horsepower. 1 horsepower is 746 watts. So 1 horsepower is 746 watt, or you can revise it like this: 746 watts is equal to 1 horsepower. So 1 watt is equal to 1 by 746 horsepower, and 2000 watts is equal to 1 by 746 into 2000. You can solve it and it will come approximately 2.8 horsepower. This is approximate answer. You can calculate the exact answer. What is exact answer? Okay. So now we'll move to question number 20. In question number 20, it is mentioned that electric kettle is there and its power is 500 watt. So power is 500 watt. Now keep in consideration whenever any instrument is mentioned and its power is mentioned, that power is hourly, means in 1 hour it uses 500 watt, not our normal joule per second, means per second. It uses 500 of joule in an hour. It is normally given as an hour number, not as a second number. So it uses 500 watt and runs every day for 2 hours. So in 1 hour it uses 500 watt. It runs for every 2 hours every day. So in 2 hours it will use 1000 watts or 1 kilowatt. Okay. So in one day it uses 1 kilowatt. Now it is asked at 10 days. So in 10 days it will use 10 kilowatt, and 1 kilowatt is equal to 1 unit. So in 10 days it will consume 10 units of electricity. Okay. Going to question number 21. Like here it is specifically mentioned that 2 kilowatt hour. In some question it will be mentioned, in some question it will not be mentioned. So power is 2 kilowatt hour. 2 kilowatt hour. So it means in 1 hour it uses 2 kilowatt of energy. It runs for 1 hour each day. 1 hour each day. So one day means 1 hour. So in one day it uses 2 kilowatt. There are total 60 days. So in 60 days it will consume 2 into 60 equal to 120 kilowatts of energy. Now we have to find the cost of using it. We know that 1 kilowatt is equal to 1 unit. So 120 kilowatt is equal to 120 units, and rate of 1 unit is 1.5 rupees. So for 1 unit we have to pay rupees 1.5. For 120 unit we have to pay rupees 1.5 into 120. It comes out to be 180 rupees for 60 days. Okay. Going to question number 22. So in an experiment to measure his power, a student records the time taken of his running up a flight to step on the staircase. So a student goes up on a staircase like this. Suppose this is staircase, and he goes up from ground to top of the staircase. So number of steps is 28. Height of each step, height of step is 20 centimeter. So total height is equal to height of step multiplied number of steps. So 28 into 20 by 100, because this is in centimeter, we have to convert it in meter. So it will come 56 by 10. We will not solve it further because this will be used in further calculations, and having 10 in denominator is always helpful to convert into points. So time is given 5.4 second. Now we have to measure the power. Now mass of student, mass is 55 kg. and g is mentioned, we have to use 9.8. So as we have already discussed in previous questions that there is only vertical movement. If there is vertical movement, work is equal to change in potential energy. Change in potential energy, delta means change. So here work is equal to potential energy's formula is mgh, and m is mass is 55, g is 99.8 or 98 by 10, and height is 56 by 10. Okay, now for going to power, power is equal to work upon time. So work is 55 into 98 into 56 by 100, 10 into 10, 100, and time is 5.4. So this 54 by 10 and 10 comes here. So this get cancelled. So after doing calculation, we will get something like 150. You can do your own calculation also. 55, 98, 56 divide 54. Oh, 5589.6 watts. This will become the power. You can get idea also from this that 55 and 54 will get cancelled. If you doing this in an exam and you don't have calculator, then this is 55, this is 54. They will get cancelled. Assume this is as 100 and this is as 56. So even up with approximation you can get it to answer up to 5600, and we are very near to this answer. Okay, so sometime approximation also help to, suppose this is a multiple choice question and where you have given some options, from approximation you can get that up to which limit your answer will be. Okay, so now going to question number 23. In this question, a bullet of mass 15 gram has a speed of 400 meter per second. So mass is mentioned as 15 gram, or you can say it 15 by 1000 kg, and speed is given, velocity is given 400 meter per second. What is the kinetic energy? So kinetic energy is equal to half mv square. Okay, so half 15 by 1000 into 400 into 400. So those two zeros get cancelled, this one zeros get cancelled, this is 2, 15 into 2 into 40, 30 into 40, 1200 joule is its kinetic energy right now when it is moving with velocity of 400 meter per second. Now bullet strikes a thick target and brought to rest in 2 centimeter. So distance traveled is 2 centimeter. After this 2 centimeter, velocity goes to 0 because it comes to rest. Calculate the average net force acting on the bullet. What happens to kinetic energy of original bullet? So what we have to calculate? We have to calculate the force that acted on bullet. So this can also be done into via two methods. One is via equation of motion, and second via work done. So I will be using here work done method because this is work done chapter based on work. You can also solve using equation of motion, because using equation of motion, what you have mentioned, given, you have given initial velocity, this is, you have given u, you have given distance, and you have given v. So using these three, and using this equation v square minus u square is equal to 2as, you can get acceleration. and using acceleration and mass you can get force. Okay, and we have to calculate the force, so you can go via this route, and here we will be using work done route. So let's start. Here bullet is moving horizontally, means in x-axis. So if object loses its energy in x-axis, then work is equal to change in kinetic energy. Okay, if object moving vertical or y axis, then work is equal to change in potential energy. If object is moving horizontally or in x-axis, then work is equal to change in kinetic energy. So here work is equal to change in kinetic energy means final kinetic energy minus initial kinetic energy. We know that final kinetic energy is 0 because final velocity is 0. If we put 0 here, this whole value comes, whole formula gives us 0. And initial kinetic energy is we already calculated, it is equal to 1200 joule. Okay, so our answer comes out to be minus 1200 joule. Now what is the formula for work? Work is equal to force into displacement into cos theta. Okay, so assume that cos theta is 1. So it is force into displacement is equal to minus 1200, and displacement is 2 centimeter. So force into 2 by 100 is equal to minus 1200. Using this, force is equal to minus 1200 into 100 by 2, 600. Our answer comes out to be minus 60,000 Newton. Means bullet was going in forward direction, but force was acting in reverse direction. That's why velocity of bullet reduced to 0. And this is an example of retardation, because force was acting in opposite direction to motion of bullet. Velocity of bullet reduces to 0. Now going to next question. We have to calculate the power of heart, which beats 72 times in a minute. So let me clear the screen. Let copy this. And what is on next page? 1.2 kilowatt. Okay. Oh, let this clear. A heart beats 72 times per minute, and its power is given 1.2 kilowatt, 1.2 watt. So we have to find work done in each heartbeat. So power is 1.2 watt. So 1.2 watt means 1.2 joule per second. We have given per minute. So in a second, heart has 1.2 joule of energy. So in 1 second, it has 1.2 joule of energy. In 60 seconds, it will have 1.2 into 60, or this is equal to 72 joule of second. Okay. So in a minute, heart has 72 joule second. And using that 72 joule, using this 72 joule, heart beats 72 times, because it is mentioned that in a minute heart beats 72 times, and in a minute heart has 72 joule. So using this 72 joule, heart beats 72 times. So using 1 joule, heart beats 72 by 72 times, or 1 times. Or for each heartbeat, heart uses 1 joule of energy as per statement. Okay. Now going to our last question, question number 25. So when loading a truck, a man lifts boxes of 100 Newton each through a height of 1.5 meter. So here is, look, here is weight is given. Weight is 100 Newton, and we have to get weight in kg. So whenever weight is given in Newton, you have to divide it by value of gravity, or g. And here it is mentioned that you can use g is equal to 10. So weight will be equal to 100 by 10, or 10 kg. Okay. Height is given 1.5 meter. Now we have to find out the work done in lifting one box. Now box is lifted. If lifting is happening, means motion in y direction, or vertical movement. And if there is vertical movement, then work is equal to change in potential energy, and that is equal to mgh. M is 10, G is 10, and H is 1.5, or 15 by 10. So answer comes out to be 150 joule. Okay. This was first part. Second part, how much energy is transferred when one box is lifted? So if work done is happening of 150 joule, then work done is what? Work is just transformation of energy. Transformation or exchange of energy. So if work is 150 joule, then change in energy or transfer in energy is also 150 joule. Now going to part number C. If man lifts 4 boxes per minute, then his power. So if he lifts 4 boxes, for one box work is 150 joule. For 4 boxes, work is equal to 150 into 4 is equal to 600 joule. Okay. Now it is mentioned that he lifts 4 boxes in 1 minute, or 60 seconds. So here power we have, for power we know it is work by time. For 4 boxes, work is 600 joule and time is 60 seconds. So it comes out to be 10 watt of power. So students, we have covered our 3 exercises with this question, and hopefully these will be beneficial to you. And if there are any doubts, any questions, you can ask in comments, and if you want the PDF, you can also ask in comment. After this, we will start our NCERT exercise, and once that exercise is completed, we will move to next chapter. and I will urge you to do these questions yourself also, because after solving question it becomes habitual to you to understand, and your habit gets changed from just cramming theory to also understanding it and also using it to solve numericals. It gives you better understanding. So hopefully you will do it, and thanks for watching. And also, if this video adds any value to you, then please like, share and subscribe. Thank you.